This is going to be lecture 2, part 2b, on how to solve for rate laws for more complicated chemical reactions. So remember from the previous video that the rate law is going to always equal the rate is always going to be equal to K times the concentration of your reactants raised to certain powers. So in this case, your reactant is H2O2, and your I minus and your H plus, and always raised to powers of M, N, and P. Okay, so those are the three variables the book chooses to indicate the order of the reaction. So really, in this problem, we would like to find the data, based on the data, the reaction orders for H2O2 I minus and H plus. So really, we would like to know what is M, what is N, what is P. In addition, we would like to also know what is K, the rate constant. Okay, as well as we would like to know M, N, and P, which is the order. Okay, so to do that, think about it. The order really is a communication to the audience. If you increase the concentration, what is its effect on the rate? Okay, so if you increase the concentration of H2O2, how does it affect the rate? Okay, that is what M is. What is M? So to do this kind of experiment, you would say, I'm going to add the same amount of I, the same amount of H in both experiments, but I'm going to, let's say, double the concentration of H2O2. Okay, that's exactly what's happened here in experiment 1 versus 2. Notice in experiment 1, okay, in experiment 2, you've doubled the concentration, right? You've multiplied the concentration by 2. But for I minus and H plus, they are the same. Okay? One variable, two controls. How does it affect the rate? It doubles the rate. Okay? So how do you find M? Easy enough to do. You would say rate of 2. And this 2 stands for experiment number 2, divided by rate of 1, experiment number 1. It is equal to K times your H2O2 concentration to the M, your I minus concentration to the N, and your H plus concentration to the P. But in these cases, in every one of these cases, you are looking at experiment 2. Okay, this 2 corresponds to experiment number 2. Okay? Then you're going to, of course, divide by rate 1. And what does rate 1 equal? It equals K times H2O2 to the M, I minus to the N, and H plus to the P. But in this case, it is going to be, again, experiment number 1. Okay, so this lowercase 1 or subscript 1 really refers to experiment number 1, right? So if you're looking at it, okay, I minus is the same, so I minus cancels out. H plus is the same in terms of the concentration, that cancels out. So you've really simplified it, right? And K is the same, so you've really simplified it to rate 2 divided by rate 1 equals H2O2 concentration 2 divided by H2O2 concentration experiment 1. So let's look at those numbers. The rates are here. Okay, so I'm going to plug those in. Rate 2 is 2.30 times 10 to the minus 6. Rate 1 is 1.15 times 10 to the minus 6. Okay, the H2O2 concentration is here. It's been doubled, so it is 0.020 to the M and 0.010 to the M. Okay, so 2.3 divided by 1.5, that's 2, equals 0.2 divided by 0.1 is 2 to the M. So really, M must equal 1, right? 2 to the 1 is 2. Now that we've found out M, we would like to know what is N. N as in Nancy, okay? So in that particular case, we should be looking at experiment 3 versus experiment 1. Why is that? Because if you look at experiment 3, I has been doubled, right? The concentration of I has doubled, okay? And the concentration of H2O2 has stayed the same, and the concentration of H plus has stayed the same. Again, we're changing one variable, in this case the concentration of I, and everything else is controlled and held the same. So again, we're going to go rate of, I'm going to do it here. Okay. Rate of experiment number 3 divided by rate of experiment number 1 is equal to, and K, got your H2O2 to the M, I minus to the N, and H plus to the P. Okay? And this is experiment 3, 3, 3. Okay? And I'm going to do the same thing on the bottom. And remember, this is now still experiment 1. We're comparing experiment 3 and 1. Now, if you look at experiment 3 and 1, H2O2 concentration is the same. That cancels out. Your H plus concentration is the same. That cancels out. That leaves you with rate 3 divided by rate 1 is equal to the I minus concentration of experiment 3 divided by experiment 1. So let's plug those in. We're looking at experiment 3. So that is 2.30 times 10 to the minus 6 divided by 1.15 times 10 to the minus 6. And your I minus concentration is doubled, 0.020 to the N, and 0.010 to the N. So if you were to do that, this becomes 2, okay? And your 0.02 divided by 0.01 is 2 to the N. So again, in this case, N is equal to 1. Okay? Last but not least, you would like to solve for P. P as in Peter. And P has to do with your H plus concentration, right? If you're looking at your generalized rate law, okay, P has to do with your H plus concentration. So again, you would like to cancel out your H2O2 concentration as well as your I minus concentration. So again, you're going to be looking at two different experiments. In this case, experiment 4 and 1. Why experiment 4 and 1? Because in experiment 4, H2O2 concentration has stayed the same as experiment 1. Your I minus concentration has stayed the same. And notice you have doubled your H plus concentration. So you're going to go rate of experiment number 4 over rate of experiment number 1 is equal to K times, I'm not going to rewrite all of that. You know that the K cancels out, right? The K cancels out. You also know that, let's look above here, okay? You know your K cancels out, your H2O2 cancels out, your I minus cancels out. So really, all you're left with is your H plus concentration. So that's all I'm going to write. H plus of experiment number 4 to the P divided by H plus experiment number 1 to the P. And again, I didn't write all the other stuff because it cancels out, so there's really no point to writing it. So again, experiment number 4's rate is 1.15 times 10 to the minus 6 from our data table. And experiment number 1 is still the same. Okay? But notice we've doubled the H plus concentration again. Okay, so again, doing the math, 1.5 divided by 1.5 is 1 is equal to 10 divided by 5 is 2, or 0.01 divided by 0.0, oh, I lost the 0.05, okay, is 2, and it's to the P. Now in this particular case, P must equal 0. Okay, why is that? Because 2 to the 0 is equal to 1, right? So 1 equals 1, that's true, okay? So in this case, the more P you add, doesn't really matter. It's still going to be, the more H plus you add it, it's still going to be the same rate. Last but not least, you need to solve for K. And again, you can pick any experiment you would like. I'm just going to pick experiment 1. So we say rate is equal to K times H2O2. Now we know M is equal to 1, I minus, and N is equal to 1, and H plus, P is equal to 0. P equals 0, so you can cancel that out because anything to the 0 is 1. So looking at the data from experiment number 1, the rate is 1.15 times 10 to the minus 6. Molarity over seconds is equal to K. The concentration of H2O2 from experiment number 1 is 0.010 m. And from experiment number 1, the I minus concentration is 0.010 m. Okay, this is all from experiment number 1. All the data is from experiment number 1. Okay, so to solve that, I get 1.15 times 10 to the minus 6 m over s is equal to k. I'm going to multiply these two together and get 1.0 times 10 to the minus 4m. So to solve for k, I'm just going to divide this side by 1.0 times 10 to the minus 4m. Sorry, it should be m squared. I apologize. Squared. Because m times m is m squared. Okay? So if I do the math, 1.15 divided by 1 is 1.15 times 10 to the minus 6 minus 4 is minus 2. And my m cancels out, so it is 1 over s, 1 over m is equal to k. Okay? So going back to what we're solving for the actual rate law. So the actual rate law is rate equals, we know what k is, 1.15 times 10 to the minus 2. I'm going to change it to m to the minus 1, s to the minus 1 to simplify it. H2O2 to the 1, because m is equal to 1, and I minus to the 1. And if you wanted to, you could write h plus to the 0. You don't need to, because anything to the 0 is 1. So you've solved for m, you've solved for n, and you have solved for p, and you have solved for k. Okay. Last but not least, let's do one more kind of problem. Actually, let's stop the video here. That was a very extensive problem. So let's stop the video here, and I will continue, and we'll call the next video Lecture 2, Part 2C. So let's stop the video here, and let's do the homework problems associated with solving for the order and k in your homework booklet.